All right, we are going to do lesson 4.2, the unit circle, and this may be our second look at the unit circle, but the unit circle is just simply a circle with radius 1 and whose center is at the origin. So the center is at the origin, and what is the value of the unit circle? Great question. The value of the unit circle is really to help us understand and conceptualize and then really make a lot of inferences about the nature of trigonometry. So if I have center at 0, 0, now I'm going to make one circle. I'm going to make this circle in degrees, if that's okay with you. Now, I am going to approach this in terms of degrees, and I'm going to deal with the special angles, the angles that we know. So this here is going to be 0 degrees. Up here is 90 degrees. Over here is 180 degrees. This is 270 degrees. This is 360. And if we keep on going, if we wish to, we would see that this is 450, et cetera, coterminal angles. But really, I'm just going to restrict myself from 0 to 360. All right, and these are very special. I'm going to do these special angles. Their first special angle is the 30-degree angle family. Now, if this is 30 degrees, I'm going to find the related angle right over here in quadrant number 2. And the related angle in quadrant number 2 is 150 degrees. And I can get that simply by going 180 minus 30, because it's 30 degrees away from the x-axis. And the related angle in quadrant 3 is 210, and the related angle in quadrant 4 is 330. And again, I can go 180 degrees plus 30 gives me 210. And then to get to 330, I can go, 360 minus 30. So really, these are just 30 degrees away from the x-axis, and those are my special angles in terms of measurement. Here, I'm going to put in my next special angle family. It's the 45-degree angle family, so that's 45. This is 135. This is 225. Over here now, this is going to be 315 degrees. Now, I could figure this out very quickly just by saying, well, I'm 45 degrees away. I'm 180 minus 45, which is 135. For my quadrant 3, I can go 180 plus 45, which is 225. Or I can go for my quadrant 4, 360 minus 45. Maybe I'll go, no, I already used green. Let's maybe go for a lime green, this color, spice things up. It's a Friday, that's what I feel like. All right, so anyways, I'm going to talk about the 60-degree angle family. Well, 60-degree angle family here, so I'm just writing all my related angles in each of the quadrants. I'll make sure I put degrees on everything. Everything's looking great. By the way, that's 270. This is not a special angle. So there it is. There's my unit circle in terms of my special angles. Now, each of these have a sine, cosine, and tangent related to them. And just so you remember, sine, cosine, and tangent really are determined by the x and y coordinates of each terminal arm. So over here, we know that this is 1, 0. So on the unit circle, the cosine of theta is equal to x. Now, this is only on the unit circle. Sine theta is equal to y. Now, a lot of people have a difficult time with locating the x and y coordinates. What I would like to reiterate to you is that the x and y coordinates remain the same provided that you stay in the same family. That is, if I'm in the red family or the 45-degree angle family, in that position, the xy coordinates are always going to be 1 over root 2, comma, 1 over root 2. We're okay with that. Now, in the 30-degree angle family, the xy coordinates are going to be 1/2, comma, root 3 over 2. In the 60-degree angle family, the xy coordinates are 1/2 root 3 over 2. Well, pardon me, I messed this up over here. Incorrect. This should be root 3 over 2, comma, 1/2. My mistake. So now this is going to be the difficult part. If you notice, there are 5 special numbers when you're dealing with the xy coordinates. So angles is one thing, but then we have the xy coordinates of the individual angles, which correspond to the cosine and sine. But I have 5 special numbers. And there we have it. These are my 5 special numbers in ascending order. So I'm just going to go around, and it's going to be very difficult to demonstrate this visually, but I'm going to start here. And I'm going to move into my quadrant 1. And I'm going to only talk about the y coordinates. Hope we agree that sine is equal to 0 here, the y coordinate. And as you move to these special angles, the sine or the y coordinates get larger and larger. Right? So really, we start off with 0, 1/2, 1 over root 2, root 3 over 2, and 1. That is, I went in this direction of ascending order. And really, this is just about getting the order correct. Now, I am going to go and talk about cosine, which are my x-coordinates right here, right? I'm going to talk about my x-coordinates. Well, what is the x-coordinate at 0? In this position, it's 1. So in other words, it's all the way over here, 1. But as I move around the unit circle, it decreases. 1, root 3 over 2, 1 over 2, root 2, 1/2, and then 0. So what we see is that the x's decrease in value as you go around the circle up until you reach this point. So a lot of people, when they're doing the unit circle, they don't worry about the x and y coordinates all around the unit circle. They only worry about the xy coordinates in quadrant number 1. And since they got a good grasp of what's going on in quadrant 1, it's easy for them to make judgments in what's quadrant 2.